All right, my daughter came home last night with a linear programming problem, and I thought I'd take a look at using Desmos to try and figure out the maximum value or the answer to the question: how many acres of each should the farmer plant to maximize his profits? It says a farmer has 90 acres available for planting millet and alfalfa. Seeds cost $4 per acre for millet and $6 per acre for alfalfa. Labor is $20 per acre for millet, $10 per acre for alfalfa. Income is 110 for the millet per acre, 150 for the alfalfa per acre. Farmer doesn't want to spend any more than 480 on seed and 1,400 on labor, so we want to maximize his profits. So the first thing we'll do is set up some constraints. I'm not going to put in the dollar signs, so forgive me. But what we've got going on here is, of course, we want our X to represent acres of millet, Y is going to represent acres of alfalfa. We want both those acres to be greater than 0. The 90 acres available will be represented by the constraint total acreage has to be less than or equal to 90. Then we have the seed cost $4 per acre for millet, $6 for alfalfa. We can spend 480 represented by that constraint. I think I have that right. Labor is $20 per acre for millet, $10 for alfalfa, 1,400 on labor. This has got to be revised here. Looks like it has to be 10 for alfalfa. So I think we're good there. All right, so what we're going to do is take these constraints, we're going to throw them in Desmos. We're going to see how that graphing utility can help us work through this problem. So I will go ahead and open up a window in desmos.com, and I will bring it over here, and we'll go ahead and start putting our constraints in. So we know, and the first thing I'm going to do is put the constraints in, but I'm going to bound the over 0 for x and y right as I put the constraints in. So for instance, we have x plus y has to be less than or equal to 90. And what I'll do is I'll put in that x is got to be greater than or equal to 0 here. Come here to 0 here. And that we want y to be greater than or equal to 0 here. So we use these squiggly brackets to put in our restrictions on our domain and range. And we will put this in as, what did we have? We had 4x plus 6y is less than 480. 4x plus 6y is less than or equal to 480. And then we had 20x plus 10y had to be less than or equal to, I think it was 1,400. That was our labor cost. So I have those in there, and I'm going to bound all of them this way. I'll just copy that down into these other, oops. Close these, close this, close this, close this. Come here. Just going to control copy that. Put it in there. There we go. Put it in there. And you'll see that I have graphed my feasible region. Now we're interested, of course, in the points that are the points of intersection. Unfortunately, in Desmos, I can't just click on them when they're in the form of inequalities, but I can create equations that are very clickable. So I'll go ahead and put in my x equals 0. I'll put in the equations represented by the inequalities. Y equals 0. And I will put in x plus y equals 90. I will put in, what was up here? I'll put in this equation. And I'll go ahead and throw this one in there also. The reason I'm doing that is because when you use Desmos, you can find intersections of equations fairly easily. And I think we're good. All right, so I can see my feasible region here. I'm actually going to turn those off for a minute. And I'm going to go ahead and you can see that you can simply click on, which one am I missing here? X plus, oops, I copied the same one too many times. All right, let's go. Let's fix this. 20x plus 10y equals 14. There's here. Okay, now I have everything. So if I click on this, I'll see 1, 2, 3, 4, 5 test points. Now, we can go ahead and throw those in and test them if you would like, or we can simply move our profit equation through the feasible region, and the last point that marks the last part of the line leaving the feasible region will be our solution. I'll show you how that works. Let's go ahead and take a look at this. So our equation for our profit is going to be P equals, it looks like we are making 110, 110x plus 150y. Now what I'm going to do is I'm going to solve that for y. And when I solve that for y, I'm going to end up with 150y equals negative 110x plus p. I know I've switched sides on you here. And now I'll divide everything by 150, and I will end up with this equation. I'll go ahead and just, let's get back to where we were here. I'll go ahead and put in here. What I'll end up is y equals negative 11/15 x plus p divided by 150. And what this allows me to do is put in what's called a slider. So I'm going to put that slider in there, and what that slider is going to do, it's going to move that equation. Now you don't see the line moving much. Here's our profit line. You don't see it moving now, but what I've got to do is I have got to get the numbers larger in that slider. So I'll make this, the highest I can go is 20, the lowest I can go is 0 for our profit, and I'm going to step 1,000 at a time. Let's see what that does for us. So you can see I'm moving that line through the feasible region at that point. Now this line represents all the profits, and the higher we move the line, the more profits we're making. But the line has got to remain inside the feasible region. And you can see we are beginning to exit the feasible region here. And it looks like somewhere around, I'll tell you what I'm going to do. I'm going to make this go by 500s or hundreds. It looks like right about there is the last time that line is in the feasible region. Right there, that's one of the nodes of the feasible region. So it looks like right about there is the last time it works through that. So I can tell now that that intersection is going to be where my profits are maximized. Let's get this out of the way. So I know that that's going to be the intersection where my profits are maximized, which is when I have 30 acres of millet and 60 acres of alfalfa. And I can kind of check my work this way if I'd like to. What I did was I went ahead and put those into um, an applet that allows me to actually automatically calculate the feasible region. And it looks like 3060 was maximizing the profit in that feasible region. But this is just maybe a quicker, once you get used to it, way of figuring out linear programming problems. I just thought I'd work a little bit of non-calculator online-based technology into the problem. So enjoy, take some time learning how to use it. I think you'll find that this is a powerful way, especially once your constraints get to be complicated and once your numbers aren't so clean, you'll find that this is a little less frustrating than doing it by hand. Thanks. Oh, by the way, before I go, if you didn't like using this method of finding the feasible region, you can always fall back on identifying the points of intersection and putting them in your equation and testing each one. Just a side note. All right, bye again.